Donaghy, and today we're going to be talking about ethanol from cellulose. What we're going to do today is called the life cycle analysis. This is a process where they take everything that goes into making a product or fuel and analyze it so that they can get a hard number on the environmental impact of the products on the environment. So today we're going to be doing this for ethanol from cellulose. First off, what is ethanol from cellulose? Much like the ethanol that's in all the gas stations that the cars running off today, it's an alcohol-based fuel, but instead of being made from corn like most ethanol, it's made from the cellulose found in all plant cells. Cellulose comes from the lignin cellulose, which is a compound found in all plants. It's a really complicated sugar. Cellulose is found in almost every free-growing plant in the entire world. Plants are used as part of their cell wall for structure. And most of the cellulose from farm plants go to waste. As you can see over here in the cell wall, that's where the cellulose is contained. So really quickly through the chemistry of ethanol from cellulose. The lignocellulose, which are really complicated sugars, are broken down into simpler sugars. That is then converted from glucose into ethanol or alcohol, plus carbon and extra heat. From then, they more or less just refine it to 95% alcohol, and then it can be burned in most cars using the combustion process of alcohol. Another really important concept that you have to learn if you want to study energy is energy return on investment. This is the amount of usable energy that you're going to get out of your fuel divided by how much energy you put into acquiring that fuel. It's extremely important in fuel analysis because no viable fuel can have an EROI less than 1. Because if it did, then you would be putting more energy into getting the fuel than you are getting out of the fuel. Just for rough figures, U.S. oil imports in 2007 had an EROI of about 17, which means for every unit of energy they put into drilling and transporting and everything for the oil, we got 17 units of energy out of it. Here's a chart of a bunch of different fuels. You can see hydros up at the top over here with like about 100 EROI. Ethanol from corn is way down here, roughly about 0. The problem with corn ethanol is most environmental scientists think that corn ethanol has an EROI less than 1, which means the production of the corn, the fuel to run the tractors, the transportation of the ethanol, the distillation process, all requires more energy than it takes than you actually get out of the fuel. Another problem with corn ethanol is it takes away from food resources and land use because it uses corn instead of the waste products of the plant. And only 2% of the cars in the U.S. can run off this fuel. As you can see here, these are a bunch of different estimates from a bunch of different private companies on the energy content or EROI of corn ethanol. Some people said it almost had negative 100,000 BTUs per gallon, which is an insane number. So why is ethanol from cellulose better than corn ethanol? Ethanol from cellulose is made from the byproducts of the plant that go to waste normally. So with corn, you would use the stalks of the corn. It can also be made from wood chips. They have another thing called switchgrass, which is specifically grown for ethanol like this. Because there's a lot more waste products from plants, the EROI will be much greater than 1. Although it still emits a lot of CO2, it's considered a carbon neutral fuel because almost all the CO2 that you're going to emit using this fuel is going to be absorbed back by the next year's crop. Scientists estimate that ethanol from cellulose would have a 70% reduction in carbon emissions over oil in the U.S. The U.S. EPA estimates that ethanol from cellulose can reduce our greenhouse gas emissions by 124% in the next 30 years. That's a lot compared also is going to be a lot cheaper than oil. A few different companies have predicted that the price per gallon of ethanol from cellulose will be between $1.90 and $2.25, which is way cheaper than the $4 a gallon you're paying now for gas. Here you can see the well-to-wheel greenhouse gas emissions. This over here is your normal gasoline. And way down in the corner there is your ethanol from cellulose, which, as you can see, is much less than any other fuel that's on the market right now. The other main concern with corn ethanol is the food versus fuel. What do we use for food? Because we have hungry people everywhere. And what do we use for fuel? Ethanol from cellulose completely eliminates this problem because you're no longer using the food products of the food, but rather the waste products that you get from it. As you can see, we have the stalks of corn, wood chips from wood processing plants, and this is switchgrass up in the corner. Land use. So growing all of the fuel to power the entire United States would be a lot of land. Increased farming leads to more erosion. The constant energy demand would also require farmers to grow with very little off-season because we always have a constant demand for energy. This would completely deplete the nutrients from the soil. Currently, the U.S. uses about 20% of its land for agriculture. If the U.S. wanted to have all of its fuel switch from oil to ethanol from cellulose, it would need another 60% of the U.S. land just for the fuel. Although some land use would be able to produce both crops and ethanol. Water use. The water use for ethanol is very high. It takes, currently 80% of the U.S. fresh water goes to agriculture, and ethanol also requires water to, in the fermentation process into alcohol. So it's very water intensive. So is ethanol from cellulose the future of fuel in the U.S.? Although ethanol is a great source of fuel, it is much better than oil, it still emits CO2 into the atmosphere. The land required to meet the U.S. energy consumption would be about 35% of the total U.S. land. Water consumption would almost double, and only 2% of the cars can currently run off of ethanol. So my final verdict is that although ethanol from cellulose is a really good fuel and much better than oil, if we were to make the entire transition away from oil, we have better options, like hydrogen fuel cells and other technologies. So it is not the future of the fuel in the U.S., I would say. Right?
Sean, fantastic. I learned a lot from you. Wait a minute, you got to come back here and get really scared.
Questions?
No. That quiet moment. Trying to look really steely. Any questions for Sean? How did you end up into this topic?
Well, last year I took sustainable energy and alternative fuels, so that taught me a lot. And I really want to, for my job, I really want to be an environmental tech company that designs alternative sources of energy.
Cool.
Yeah.
Right. Follow your passion. Exactly. Okay. Let's thank Sean. Okay. There we go. Woo, 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 woo. Ellie and Sam. We have a double date for you. Here we go. Can you push this? That's a good idea. Maybe. Oops. Hold on. Where is it?
On the glass.
Is that it?
Yeah.
Sorry.
Hope this works. Oops. Copy it, and then I go to my browser and see the picture of the day. See what's going to be. Ooh. Oh, what is that? Go away. And paste it in.
It was, you did it as an object.
Okay, you go there. Go back. Smarty pants.
Yeah.
The theme of China the Water We campaign.
There. Now, go back to your PowerPoint. Right there. And click here. It's all about technology. All right. Okay, here we go. Ellie, LeBlanc, and Sam Worley. Maybe. Oops. Back. Is a little button again? No. Right here.
Yeah, you're
Right there. Right there.
I know, but we gotta start from the beginning.
Oh. You're picky, huh?
There we go.
Maybe not. All right, there they go.
All right, so I'm Ellie and this is Sam, and we did our project to kind of educate you guys on one of the bigger issues facing the environmental field today, and that's the water crisis in China. So,
It's like a little background on China. Everybody knows where China is, like geographically. It's like 22 provinces, but like the big thing you want to take away from this is of the 20 most polluted cities in the world, 16 of them are in China.
And if you look, obviously we know the population in China is huge. And if you look at future projections, you can notice that it's starting to reach its carrying capacity. So eventually the population is going to have to start going down because the natural resources can't support a population.
But if they're one child per family for some years now, how come it's still rising?
It's
Their population is
it's,
just.
it's still it's slowing. It's at a slower growth rate. It's
Okay.
just like the acceleration is going down, but the
All right, not enough people
That
are,
didn't make
not enough are dying yet, okay.
and this is just a good quote that kind of sums up.
The Chinese economy and why it's like, why the economy is going like downhill because of their environmental resources. So the pursuit of economic growth has been the priority, overshadowing the vital issues of water resources and ecological balance. And that's from a Chinese newspaper.
And this is just a graph showing the general economic growth of China compared to the U.S. And a big thing to take away is just the gap that's rising between China and the U.S. Just kind of goes hand in hand with the environmental crisis, and we'll go more in depth with that later on. And here's just a map of all the water in China. You can see the extensive river networking. It feeds right into the bigger population areas along the coast, and it just shows that the areas where there are bigger populations are heavily reliant on the water there. And if we look at this chart, you can see that the cities where the huge populations are have some very serious problems with water pollution compared to rural China, and that's going to have a huge impact on the population.
A lot of the water pollution is like over allocated. Like they try and use their rivers like way too much for their own good. And most of the rivers in China are polluted, and Chinese they lack a lot of environmental laws that would protect rivers in other countries, U.S. and Europe. 300 million people lack access to safe drinking water in China. It's an astounding number. Large stretches of rivers are dead and dying just because the pollution is so overdone. They've gone so far into pollution that recovering from the pollution in the rivers is almost impossible.
And we'll show you guys some really scary pictures of that later on.
Yeah, and then the groundwater aquifers are overpumped, so desertification is coming in in the Gobi Desert, which is middle of China.
And you can just see some of the effects here These are just current pictures of the situation there, and this is found all over the country. In highly populated areas, as you can see, there's just images of industry there, factories, the waters are disgusting. Wetlands are shrinking, natural resources being depleted. And
Like you can see, like just pieces of the river, just like absolutely disgusting. And then people have to like live off that, and like they do their laundry, like it's like the rivers are like so polluted that like they affect the livelihood of like almost all people in China.
And another even scary thing about China's situation is that they're really susceptible to water-related disasters. Like for example, well, in general, they're very susceptible to flooding and drought, but also they've had some serious environmental problems with chemical plant explosions and chemical leaks into the water, and they're not doing a whole lot to stop it just because they don't have a lot of government regulation that's effective and efficient. One example is in 2005 at the Jilin chemical plant explosion, 100 tons of benzene pollutants were leaked into the water, and it was horrific, the amount of people that were without clean drinking water.
Another disaster was in 2007, Jiangsu province, and like all around like suffered like really big blue-green algae outbreaks, which is like a cyanobacteria, and that creates a cyanotoxin, which causes eutrophication of water, which is like the reduction of like oxygen in water, and that killed like a lot of the marine life in the area, and it also led to like cyanobacteria is like a study, and it's like led to Lou Gehrig's disease in humans. So it's like the algae outbreaks. I think we have photos coming up. But bottled water is like scarce in China because the water is like they need clean water and they can't get it from like anything else.
So this is just some of the citizens in Wuxi, China from the previous slide. And if you notice, if you go back one slide, on the map here, where the city is right on that waterway. The entire population is severely affected and impacted by the water. A lot of them make their livelihood off of the water there as well.
And this is like blue-green algae outbreak, and like you can see like the algae bloom as it comes in on Lake Tai, and then Yunnan Lake as well is like completely polluted. Like these are just all photos of like that's like a river basin in China, and like all these rivers are just like so overpolluted.
These are actual images. Like, can you picture working in water that is this contaminated? I mean, we have people working here and here, fishing. A lot of them make their make their livelihood through the waterways, and you can just see how negatively impacted they are. Also, just another example of disaster that affected was another toxin spill in 2006. For a few years there, they had a considerable amount of water pollution-related incidents, and especially in the Sichuan province, surrounding a lot of the factories and industrial areas.
Flooding is like very prevalent in China. Like a lot of Chinese. Like a lot of the rural population lives on floodplains, which leads them to susceptible to lots of flooding. And like of the top 5 worst landslides from floods, all of them happened in China.
Just more examples of flooding.
The Chinese lost over 110 billion yuan just from flooding, and more than 5,000 people were killed in 2005 from floods.
Examples, and this slide is just to prove that this is kind of just an extra factor that China has to worry about, and that's that it is susceptible to flooding just by the way that the water is set up there. In 1931, there was a really severe flood where the casualties were estimated from 3.7 to 4 million people.
And this is, we also like put this up here just to show like over time, like from 1931 to 1959 to now, like China's faced these problems for like so long, and they're still not doing anything about it. Droughts are also like, it's funny because there's like flooding and droughts. China's such a big country, like you have all these different factors affecting their water supply. Like the like decreased rainfall led to like a lot of the dried up water supply reservoirs, which were already being like overused and overpumped out of rivers. So now you have drought and where you try to keep your water, and your rivers are being overpumped, so they're decreasing. So like it affects it doubles your loss of water.
Some more amount of some severe droughts in China.
Like we've just put like in United States versus China, the difference in like their policy is like after the United States has environmental disasters like the Love Canal, we've like done, we created the EPA, we created a lot of like environmental policy to like help like protect our water, protect everything. And China's yet to do that. We're just like gonna move on to a video. Video.
Aim is to secure sustainable development through a strict water management system. 张亚静 has more.
Water pollution in China poses a huge threat to the development of a sustainable water management. Statistics of a joint report from several Chinese universities show more than 1/3 of the country's industrial wastewater flows directly into rivers and lakes. The water environment in most cities around the country is declining. An official report from the Ministry of Environmental Protection shows among the investigated 131 rivers that flow through cities, 36 are severely contaminated and nearly 60 others polluted. Since the Songhua River benzene pollution incident in 2005, over 140 pollution cases have been reported. The Yellow River, an important water resource for North China, is suffering from serious pollution. Nearly 40% of its mainstream has been severely affected. The country's longest river, the Yangtze, is being threatened by a continuous flow of billions of tons of polluted water. And the situation is no better for the Huaihe River, in which the country has invested most. It remains a severely polluted river. Water pollution has resulted in enormous economic losses. Experts point out that water pollution is a joint result of human factors, society, and economic development. 张亚静 CCTV.
Thank you. Ellie, Sam, come out front. Okay, questions for Ellie and Sam? There we go.
What made you guys choose this topic? And what drew you to it?
I've been to China 3 times, and like seeing like all the water, like it was like it's disgusting. It was bad. So I don't know. I felt like it was like an issue that needed to be like touched.
Yeah, and it's an environmental impact that's huge just because China's impacts affect the global economy, the global environmental situation severely. So it's something that needs to be brought to our attention.
You're right. I've been there too, and I was stunned not only by the water but the air. I've never seen air like that, and it's not just China. It's third world countries all over the world that don't have the kind of environmental laws we have. So when we have a class like this one that advocates, going to the tap water and using reusable bottles, most of the world that doesn't work. The plastic bottles have a real service there because they give people at least the option for clean water. Thank you so much. Hey, sorry to rush everybody. Where are you? Marissa! Let's see if this works. This is, goes to the internet. You ready?
I have my laptop.
It worked last night. Loading. This is the problem. Again. Technical difficulty. It's going to be a lot. Let's y'all go get it and have it ready to go. And let me jump to Alex. Okay? Come on down, Alex.
Do you mind if I use my flash drive?
Huh?
I said, do you mind if I use the presentation on my flash drive instead?
Okay.
I just
Sometimes those go more slowly, but we can try.
I mean, we can transfer to your computer. It's just, it has like a couple more images that I think are cool.
Okay.
Fits.
It fits. Let's do the transfer first. We'll just put it right on the desktop. Nope, that's me. And there you are. We're going to see everything that's on here.
That's okay.
Okay, where is it? There it is. I take this one, just this. That's all I need?
Yep.
Do I need any movies that go with it or anything like that?
No, it links to the internet. It doesn't just YouTube.
You know, like this. Go away.
Yeah, so you can just pull it out.
It fusses at me when I do that.
Yeah, I like to be safe.
Okay. You ready to go? Okay, you're going to dance with this. You'll cut that side button, and here's your clicker. Okay, so 8 minutes. Okay. Yeah. There we go.
All right, so I'm Alex, and yeah, I did my project on the Guy hypothesis, which is like, as you can see here, this idea that the Earth is kind of like an organism in its own right. It has a bunch of feedback mechanisms and things that keep it in check, just like a human body does. Like the human body, in case you don't know. Well, I'm a biology student, so I kind of have to explain some things that would normally be kind of common knowledge for me. But the human body keeps its salt balance, keeps its water balance. Like it does a whole bunch of things that keep it alive, and the Earth does the same thing. So James LeBlanc was the guy who kind of proposed this in the first place. Basically, like I said, everything is interconnected. So every like biome, every all the animals that make up the ecosystem within that biome provide functions that feed into other biomes and other organisms in different ecosystems. You can see here, all living matter and all non-living matter is dependent on each other. So here's another kind of overview thing. So for example, here we have the CO2. The Earth sequesters CO2 in its geologically and in the living matter that makes up the Earth. And without that process, there would be way too much CO2, and we would all be dying, which is, kind of what's happening. Maybe not dying, but we're releasing all that CO2 in a way that Gaia doesn't really like. And we can see the effects when we kind of perturb the system that's already in check. It starts to have negative repercussions. Another example here is nutrient cycling. Kind of famously, there's this area in Africa that ejects a lot of dust into the atmosphere, and it moves over the Atlantic Ocean and actually fertilizes the Amazon basin. And there are different arguments as to how important this really is, but some of the people think that without this nutrient deposition, the Amazon wouldn't be as prolific as it is, which obviously has immense repercussions because the Amazon keeps us colder, sequesters a whole bunch of carbon. So yeah, so this used to be kind of controversial because it invokes a lot of things that kind of clash with the modern view of science. But now it's rather accepted because we can see now things like this dust deposition, things like, I'll get into later, like cloud formation by microbes in the ocean. But this is a picture of the early Earth. It's kind of horrendous. But you can see bacteria form these things called stromatolites, which are basically just like aggregations of the secretions of these microbes. And the early Earth was basically populated almost exclusively by these microbes. And I'll show you a video, but bacteria are kind of responsible for the way we live, and they keep everything in existence. This is Richard Dawkins. I put him up here because he's kind of a really mechanistic kind of guy. He views life and the Earth and things as kind of like machines. So,
What's his name?
Richard Dawkins.
Okay.
He famously wrote The Selfish Gene. Some people might have heard of it. He's a really big deal in evolutionary biology. But Rene Descartes once said, while his students were dissecting live dogs, the dogs would cry, obviously, because they're alive. And he said, pay no attention to the, pay no attention, it's merely the creakings of a machine. And like, that's kind of an idea that's kind of reverberated throughout science today. You can see like really horrific experiments by genetic scientists and things where people view things as machines. And obviously that's horrific to us, but after you spend 20 years in the field of science, you start to become almost brainwashed and you become detached from the things that at one point inspired you to actually go into them. So this is kind of, I mean, he's not evil, but he looks at genes as entirely disparate from life, and it's a really detached view, and it kind of really exemplifies how Descartes has moved into the modern view of science and made things really just dead, and it's like steel on steel, gears turning. Because Daisy World was the first model that LeBlanc created, and it's really interesting, and I don't know if I have enough time, but I really want to put this video. But I think I can explain it instead. Basically, there was a planet. This is a model, so it's all mathematical and computerized. There's a planet, and as opposed to having thousands of species like we do, you put two species on it, black daisies and white daisies. And you put a sun with this planet, and the sun slowly heated up, as our sun is now. And as the sun heated up, well, first it was too cold. So the black daisies were favored because they were black, so they retained more heat. And as the sun got warmer and warmer, white daisies became more prevalent because they were able to kind of mitigate that heat loss. But we have to think of the overall effects of these daisies on the planet. So black daisies are turning the Earth black. So they warm the planet up to a point where they appreciate. And the white daisies do the opposite. So the amazing thing that really was garnered from this modeling is that throughout the entire course of the sun getting brighter and these species altering, the planet stayed the same temperature the whole time because it was mutually beneficial for each planet to maintain a kind of equilibrium. And when you multiply this, you just add a whole bunch of species in, you add different biomes and different nutrient cycles. It's the same thing. And the more tightly coupled these species become, the more powerful this becomes because you have more and more fail-safe mechanisms. So life generates life, and it creates conditions that are conducive to life. So as planets succeed, they keep themselves in check. As we've kind of learned through like the way that volcanoes and subduction zones and all these things are intimately tied to each other. To try to exemplify that, I'll show you a video. This guy's like the man. He kind of is like more inspiration for this project.
Uh-oh.
Oh my god, it's so small. Okay.
I think this is a long intro.
But you can make a good case that bacteria are centrally involved in the movements of the continental plates. I can tell you the story of it if you like.
Yes, please.
Yeah, it's got to do with water, you see, because you have to have water for plate tectonics. The reason is that the water acts like a sort of lubricant. You know, as you probably know, part of the plate tectonics process is the arising up from the mid-oceanic ridges of a sort of semi-molten, very viscous rock from below, from deep below. It comes up, it solidifies and moves sideways. And then eventually it sinks at the continental margins and goes back. Yeah, and as this plate of basalt rock moves sideways, it absorbs water. And there are certain chemicals in the rock that just love the oxygen in the water. And they want to get hold of that oxygen, and they do. They strip the oxygen out of the water, and that leaves free hydrogen. Now, hydrogen is so light that the Earth's gravitational field can't hold it down. And so it tries to escape back to space, where it really likes to be. You know, hydrogen likes to be in interstellar space. That's where it feels most comfortable. So it sort of tries to move out. And of course, if you lose all the hydrogen, which would eventually happen through this process and some others, but let's focus on this one, the Earth would lose its water because you have to have hydrogen to make water. The oxygen would be bound up in the rocks and the hydrogen would go off to space. And the Earth would dry out. But this doesn't happen because hydrogen is very important for metabolism. Living things need it to liberate energy from food molecules. And so bacteria in the sediments capture the hydrogen and use it to liberate energy. And by various means, they recombine the hydrogen with the oxygen and reconstitute the water. So this means that thanks to the bacteria, water is maintained on the planet. And because there's water on the planet, plate tectonics can continue. And therefore the continents that ride on top of the basalt, seafloor basalt, like corks on top of water, those plates can then move around. And we can have mountain building and volcanoes and subduction zones, all because, well, in part because of what tiny little bacteria are doing down in the seabed sediments and capturing this hydrogen that would otherwise escape to space. This proves, it doesn't prove, but it demonstrates what Lynn Margulis has said, I think, several times, that it's the
All right, we'll stop there. Lynn Margulis is another scientist. But,
I'm not sure what to think about that.
yeah, I was wondering how you would put in your own opinion there. But if I can get this to work again.
Yeah, you're almost at it.
Yeah, I figured.
Yeah. Why don't you go wrap up?
All right. I'll just show you guys some awesome pictures. Yeah, so like the main reason why this is kind of contradictory or controversial is because, like I said, Descartesian kind of thoughts of the world being, you know, a machine really kind of clash with this idea, because this guy, a lot of people think he's just like touchy-feely and, you know, he's like into his like hippie side of science. But, you know, it's scientifically justified hippieism. So, you know, everyone knows this movie and everyone's like blown away. There's actually like a psychological condition where people will be depressed after watching this. Because, and that kind of just like made me angry. Because like if you just watch Planet Earth, it'll blow you away. These are the Tupulis in Venezuela, home of Angel Falls. Like, I think this is Mount Roraima, inspiration for Sir Arthur Conan Doyle's The Lost World. This is the Sahara Desert. This is Patagonia in also South America. This is the Grand Canyon. And these are trees called baobabs in Madagascar. So yeah, if you guys have time, watch the rest of that interview by Stephen Harding. It'll blow your mind.
Okay, come out here.
Oh yeah.
Take some questions.
Quick question. So I wanted to understand your verdict was that basically global warming, like we shouldn't worry about it because the Earth will fix it itself.
Marissa, you want to come down?
Yeah. See, I have my own theories about that, but I don't think I didn't mean to project that at all. For life in general, for the planet in general, it's not a big deal. But for us, it's a really big deal. You know, when you poke a stable system, you know, it causes ripples, and there's an effect that kind of reverberate through it. But the planet will be okay. We won't necessarily be. I had a good point there. Oh, actually, something that I've been trying to research is that obviously we have glaciation periods, right? So the planet gets really cold, and that's relatively unavoidable, especially for humans. All we have to do is live another, like, I don't know, 40,000 years. There's debate, but if we live another 40,000 years, we'll have to go through a, you know, an ice age. Theoretically, because we're making the planet warmer, we might not have to go through an ice age, which is kind of good in the long run. But if we did if we put carbon into the ice age slower, we wouldn't kill so many species, so it's still kind of bad. But it kind of gives you like this view that's it's bigger than you. And you can see that maybe things aren't so bad.
All right. This may not work. Let's try it. Maybe they'll have to hold it up. Where's detect displays? Why I usually don't do this. That's not happening all the time. That's something. Windows. Arrangement. Mirror displays. Now, we just get back to your movie. There it is. Where is it? Where is it? Okay, here we go.
Hi. Marissa. I chose to do my project on ozone depletion and the correlation with skin cancer. Last year, my mom actually got diagnosed with skin cancer, so this kind of hits home for me.
Ladies and gentlemen
And there it is.
of the class of '99, wear sunscreen.
In 1985, scientists first determined that there was a hole in the ozone layer, resulting from ozone depletion from CFC. Since that discovery, ozone depletion has been a major problem affecting humans and ecosystems on Earth.
Experts are reminding all of us to protect our skin whenever we're outdoors.
The number of people being diagnosed with disease every year is on the rise.
The main cause for skin cancer is too much sun exposure.
Learning the facts about skin cancer and understanding the ways to protect yourself is smart. It can even save your life. This is important for outdoor workers since you work outside every day and are often in the sun almost all day. In Canada, the number of people getting skin cancer is increasing. 1 in 3 new cases of cancer is skin cancer. Although skin cancer is generally treatable and has a very high cure rate, it can be deadly. A change in attitude and action towards the sun and protection is needed. Your risk for getting skin cancer depends on 2 things: how much sun you get at work or during recreation, and how your skin reacts to the sun. People who are fair-skinned, have light-colored eyes, are freckled, are unable to tan, burn easily, or have a lot of moles on their skin have a higher risk of getting skin cancer. Those who are in the sun regularly or those who are sunburned as a child or an adult are at a greater risk. People with black or brown skin do have a lower risk of skin cancer compared to those with fair skin. In Canada, the sun is most powerful from April to September, between 11 a.m. and 4 p.m. But it's not just hot, sunny, clear days when the skin can get burned. Damaging rays can pass through light cloud cover or be reflected off surfaces such as concrete, sand, or snow. Just because you can't feel the rays directly doesn't mean they're not reaching you. While fair-skinned people's skin is easily damaged by the sun, darker-skinned people can still get sun damage, leading to premature skin aging or skin cancer.
Do you wear sunscreen?
Sometimes, yeah.
When?
The beginning of the summer, but I stopped like partway through the summer once I get tan.
So you don't wear it every day?
No, I definitely don't I only wear it if I'm go to the beach or gonna be outside with my shirt off for a long period of time. But I won't just wear it if I'm. Shut up. I won't just wear it on an everyday basis.
Do you get sunburns often?
No.
No.
It's my Italian skin.
Oh yeah?
My sexy all the Italian skin.
Hello, my name is George. I'm from Byron Bay, Australia, which is about 800 kilometres north of Sydney, for those of you that don't know that. And I'm here to talk to you about Australia and the environment. Australia actually has the highest rate of skin cancer in the world right now. Australians are 4 times more likely to develop skin cancer than any other kind of cancer. 2 out of 3 Australians will be diagnosed with skin cancer before the age of 70. Melanoma is the worst kind of skin cancer, caused by ultraviolet radiation. It is the 4th most common kind of cancer in Australia.
Joe, so both of your parents have had skin cancer?
Yes, they have.
But now they're okay?
They are. They both got it treated. They both got it removed when they were diagnosed, so they're much better.
What types of skin do you have? What descent are you?
I am Irish, English, and French Canadian, and Italian.
So you're mostly light skin.
Very fair skin except for the Italian.
Has your doctor told you that you've had like a high risk for skin cancer because they have had skin cancer?
It is genetic partially, and my doctors have told me especially to be wearing in the sun.
Do you wear sunscreen?
I should wear sunscreen more than I do. The only time I ever wear it is when I go to the beach. My doctor has recommended to wear it every time I'm in the sun, but I'm too lazy to actually do that.
Do you go tan?
I do not.
I hope you don't get
Don't ask me, I'll never tell. I looked to you as it fell, and now you're in my way. I trade my soul for a wish, then you
Marissa, questions for Marissa. Do it protected. Do it safely.
Are there any health risks to using too much sunscreen?
Actually, if you put too much sunscreen on your face, it could cause you to break out, but that's not it.
Pimples. Oh no! Have you ever gotten it in your eyes? Stings. I think we'll shut down here. Thank you all for a wonderful semester. How many of you are graduating? Woo! Congratulations! Above all, stay in touch. Bye!
Oh, no.